Hey everybody, Mr. Bucko here with a couple of examples on solving systems of equations with multiplication and addition. First example that I have up on the screen here is solving the system of equations 2x plus 3y equals 18 and 5x minus y equals 11. And we are going to use multiplication and addition to solve this system. And we're going to use multiplication because if we look at these two systems, or this system of equations, these two equations, we notice that our x terms are lined up, our y terms are lined up, our equal signs are lined up, and then our constant terms on the other side of the equation are lined up. And we'll notice that none of the coefficients are opposite. So if we jumped straight to addition and tried to add these two equations together, neither of the variables would go away because neither of them have opposites. So we would either want these two to be opposite numbers, we would want this to be a negative 5, or we would want this to be a negative 2, or we want this to be a positive y, so we'd kind of want that 3 to be gone, or we would want a negative 3 right here, and we already have a negative 1, but we won't want that to be a negative 3. So what I'm going to do with the bottom equation, because it seems easiest to me to multiply the bottom equation by 3 so that this right here becomes a 3. But if we want this to become a 3, we have to multiply everything by 3. So I'm going to take the bottom equation and multiply it by 3. Because I can't just multiply one term, I have to multiply every term in the equation. So in doing that, the new system that I have is the same equation up top. That didn't change. I didn't touch that one at all. But the bottom equation becomes 15x minus 3y equals 33 because I multiplied each of the terms in that second equation by 3. Now I'm in a position where I can use addition because now one of the variables, y, has opposite numbers in front of it. It has a positive 3 and a negative 3. So if I add these together, now y will go away. So adding these equations together gives us 17x. The 17x comes from 2x plus 15x is 17x. The y's are gone because they're opposites. And then the 51 comes from 18 plus 33. And with that being said, if 17x equals 51, that means that x has to be equal to 3. This is a 3 there. Sorry, it's off the screen a little bit. But we have x is equal to 3. Now that we know that x is 3, so our x coordinate is going to be 3. We have x comma y. Now that we know that x is 3, we take that 3, plug it in to x into either of the equations we want to, and solve for y. So I'm going to plug it into the top equation and make this x a 3 right here because x is 3 as we just found, and then solve for y. So we'll have 6 plus what gives us 18? Well, 6 plus 12 gives us 18, so therefore y has to be 4. So the solution to this system is x is 3, y is 4. And we can write that as an ordered pair because that's where these two lines would intersect if we were to graph them. Or you can say x is 3, y is 4 as an ordered pair. Either one is just fine. Next example, we're going to use multiplication and addition again because, once again, we notice that the x terms are lined up, y terms are lined up, equal signs lined up, constant terms lined up. But if we were to add these together, neither variable would go away because these are not opposites, nor are these. So we can pick and choose which variable we want to go away, and either variable would be reasonably easy to eliminate based on the multiplication that needs to be done. So we can take a pick. We can multiply the bottom equation by negative 2 so that this 5 becomes a negative 10, or we can multiply the top equation by negative 4 so that this 3 becomes a negative 12. You can do either one. What I'm going to do is multiply the bottom equation by negative 2 so that this 5 becomes a negative 10 and then our x's cancel out, which is what I chose to do. So I multiply everything by negative 2 and then I'm going to write the new system. Top equation doesn't change. I didn't touch it. Bottom equation becomes negative 10x plus negative 24y because negative 2 times a positive 12 is a negative 24. And then the 22 becomes a negative 44. Now when I add these equations together, the x's cancel out because they're opposite, and we have negative 21y, because 3y plus negative 24y is negative 21y, and this equals negative 21 because 23 minus 44, or 23 plus negative 44, is negative 21. So therefore, if negative 21y equals negative 21, y has to be equal to 1. Sorry, once again, that's off the screen, but this says that y is equal to 1. So now we know y is equal to 1, so we can plug that in. We can say our y value, our y coordinate is 1. And now that we know that y is 1, we can take that 1, plug it into either equation we want to. Doesn't matter which one you pick. I'm going to pick the top one. I'm going to make this y a 1 because y is equal to 1, as we just found. So now we have 10 times what plus 3 times 1 equals 23. Well, this right here is 3. So what plus 3 is 23? 20. We want this 10x to be equal to 20. And if 10x is equal to 20, x has got to be equal to 2. So our x value is 2, and the solution to the system is x equals 2, y equals 1. And you can write that actually as x equals 2 and y equals 1, or as an ordered pair, as we see here.